Okay. In this video, trick to find number of isomers by using if molecular formula given. Important molecular formulas we discuss. First one is C4H10O. Okay, before going to this, we need some fundamental basic concepts. First concept is number one concept. First concept, 4 carbons alkyl group. In the organic chemistry, 4 carbons number of alkyls. Number of alkyl groups. This is a trick. You must and should know that. 4 carbons alkyl group, how many? Number 1, N-butyl. N-butyl structure we know that CH3, CH2, CH2, again CH2. This is N-butyl. Number 2, 4 carbons, name N-butyl. Number 2 is the isobutyl. Isobutyl structure. Now it is CH3. Iso means same methyl group. 1 carbon, 2 methyls, same. Next is CH2. Number 3. This is the trick, basic principle. Secondary butyl. Secondary butyl means one CH3, CH, again CH2, CH3. Secondary butyl. Number 4, tertiary butyl. Tertiary butyl means one carbon with 3 methyl groups CH3, CH3, CH3 and open bond. This is the secondary butyl, this is the tertiary butyl. Total how many possible? 4 only possible with 4 carbons. 1, 2, 3. 4 carbons, number of alkyl groups, total 4 only. Next fundamental basic point, second point is 3 carbons alkyl group. 3 carbons alkyl groups. 3 carbons alkyl groups, how many? Only 2. One is CH3, CH2, again CH2 open bond. What is this name? It is N-propyl. N-propyl. Next second one is isopropyl, number 2. CH3, again CH3, now CH bond. What is this name? Isopropyl. So with 3 carbons only 2. 1, 2. N-propyl, 1 isopropyl. Next these two enough. Means ethyl also we required, but with 2 carbons there is no different alkyl groups. With 2 carbons. With 2 carbons, what is that? CH3, CH2. Only ethyl is possible. There is no other. So these fundamental basic points are required for not only this isomer. If you want another isomer also, C5H12O, next C6H12O, next C6H10, number of alkynes, next C6H14O. In this all molecular formulas, we can use this trick. 4 carbons alkyl groups, how many in the organic chemistry? 4 only. First one N-butyl, isobutyl, secondary butyl, tertiary butyl. Next 3 carbons alkyl groups, how many? Only 2. One is one N-propyl, N means straight chain, isopropyl. Iso means 1 carbon 2 methyl groups, isopropyl. Now we move to the C4H10O. They are the basic concepts. Now see that C4H10O. So here 4 carbons are there. Then for this one, what possible? Alcohols plus ethers possible. Next, aldehydes, 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 ketones, ketones. These are not possible. Aldehydes and ketones, these are not possible. If you want how to this point means you can cross check. With 4 carbons, 1 alcohol you write down. CH3, CH2, 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 OH. What is the molecular formula? 4 carbons, 1 oxygen. Okay, but hydrogens are important here. Hydrogens how many? 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 1, 10. So, formula satisfied for alcohol. If you want aldehyde, you write down 4 carbons aldehyde. CH3, CH2, CH2, CHO. 4 carbons, 1 oxygen. 4 carbons, 1 oxygen. Hydrogens are important here also. 3 plus 2, 5 plus 2, 7 plus 8 only. So what is this molecular formula? C4H8O. So formula not satisfied. That's why for this formula, aldehydes and ketones are not possible. If you want ketones, you write down 4 carbons ketone. CH3, C double bond O, CH2, again CH3. Total carbons how many? 1, 2, 3, 4. Okay. Oxygens 1. This is also okay. Oxygens, carbons okay in all, but hydrogens are important. 3 plus 2, 5 plus 3, 8. So this molecular formula also want C4H8O, but they give C4H10O. This is the way. One compound to formula you can cross check. It is easy. Need not to by heart C4H1, CnHNO, CnHNO, CnH2n plus 4. Need not to by heart. Simple trick it is to find the molecular formula to functional groups, the alcohols. Then you write down with 4 carbons, ether also 1. Okay, I wrote the one ether. CH3, CH2, O, CH2, CH3. Now your carbons how many? 4 carbons. Okay, carbon satisfied. And oxygens 1 oxygen satisfied. Main important hydrogens. 3 plus 2, 5 plus 2, 7 plus 3, 10. Okay, satisfied hydrogen also for ethers. So C4H10O. And alcohol satisfied, ether satisfied. That's why for this formula C4H10O, alcohols possible and ethers possible. This is aldehyde not possible, ketone not possible. This is the first point. First point completed. Okay, then we move to the second point, number of isomers. So what is the formula given? We got the C4H10O. Now, first according to first basic concept, 4 carbons alkyl groups. Alkyl groups you write down. So one is one CH3, CH2, 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 N-butyl. What is this name? N-butyl. Next one is one isobutyl. CH3, again CH3, CH2 bond. This is one isobutyl. Trick purpose, trick 2. Next, secondary butyl. CH3, CH bond, CH2, CH3. What is this? Secondary butyl. Next, tertiary butyl, fourth one, CH3, again CH3, here also CH3, then group is the tertiary butyl. So 4 alkyl groups write on 1, 2, 3, 4. Now see here. If you write the OH group here, OH group, What is this name? N-butyl alcohol. If you write the OH group here, what is this name? Isobutyl alcohol. If you write the OH group here, what is this name? Secondary butyl alcohol. If you write the OH group here, what is this name? Tertiary butyl alcohol. So this is the C4H10O number of alcohols possible. Now here only if ethers, these are the number of alcohols total 4. Ethers, ETH, ERS, ethers. ETH means 2 alkyl groups are present for oxygen both sides. So I take the one line. Number of ethers means 1 oxygen. Here first 1 carbon left side, 3 carbons right side. So 1 carbon left side means what? CH3. 3 carbons right side means what? CH2, CH2, again CH3. And we know that 3 carbons alkyl, this is the N profile. And how many possible? 2 only possible. So immediately write down another one. Oxygen, CH3. Isopropyl also possible. CH3, again CH3. What is this? Isopropyl. This is also left side 1 carbon, right side 3 carbons. Just now I explained 3 carbons alkyl, 2 only. One is N-propyl, another one is isopropyl. Now you can change this number. Ether, this side left side 2 carbons, right side also 2 carbons. So left side 2 carbons means which group? 2 carbons alkyl is the ethyl. And this side also which group? Ethyl. CH2, CH3. And we know that ethyls, how many ethyls? Only one ethyl only. Ethyl only. There is no isoethyl, secondary ethyl. No, only one. That's why this is one ether. And these are how many ethers? 2 ethers. Total 1, 2 plus 1. Total 3 ethers here. Number of ethers 3. And here total number of alcohols how many? 4 alcohols. So total alcohols 4. That's why total structural isomers 4 plus 3 is equal to 7. This is the trick. Now in this, by using this formula only, just I give the another molecular formula. What molecular formula I can explain? C4H10O. Now how many alkyl groups are possible with 4 carbons? 4 alkyl groups. One is called C3, CH3, CH2, CH2, again CH2 group. This is N-butyl group. This is which group? N-butyl group. So instead of this molecular formula, I can use this one. C4H9Cl also, same trick used. C4H9 means 4 carbons alkyl. Here also what you can use? One time N-butyl, another time isobutyl, next secondary butyl, next tertiary butyl. So for this one, how many structural isomers? 4 only. So N-butyl chloride, isobutyl chloride, secondary butyl chloride, tertiary butyl chloride. For explanation purpose, I wrote here groups, alkyl groups. Total how many? 4. So I write the 4. CH3, CH2, CH2, CH2 bond. This is N-butyl. Next, this is the isobutyl. Next, and this is the secondary butyl group. Secondary butyl. Next, this is the tertiary butyl. Tertiary butyl group. Tertiary butyl group. Very important trick. So if you write the chlorine here, so what is this name? N-butyl chloride. If you write the OH here, What is this name? N-butyl alcohol. If you write the chlorine here, what is this name? Isobutyl chloride. If you write the OH instead of chlorine, isobutyl alcohol. If you write the chlorine here, what is this name? Secondary butyl chloride. If you write the OH here, secondary butyl alcohol. Next, in this one, here chlorine in the bond. If you write the chlorine here, what is this name? Tertiary butyl chloride. If you write the OH group here, what is this name? Tertiary butyl alcohol. So this is the first technique for C4H10O. Next molecular formula. We go to that C5H12O. Second molecular formula C5H12O. For this one also you can cross check. For this alcohols possible, ethers possible, aldehydes not possible, ketones not possible. For NEET JEE purpose, these are enough 4 functional groups. You can cross check alcohol possible or not means 5 carbons alcohol, you write down one alcohol, CH3, CH2, 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 again 1, 2, 3, 4, 5, CH2, OH. So 3 plus 2, 5, plus 2, 7, plus 2, 9, plus 2, 11, plus 1, 12. So hydrogen satisfied. Already carbons 5, oxygens 1, that is satisfied. So alcohols satisfied. Now ethers means 5 carbons ethers. CH3, CH2, oxygen, CH2. For molecular formula, cross checking, CH3. So ether, see that here 1, 2, 3, 4, 5. 5 carbons, oxygen 1. Hydrogen is important. 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 3, 12. So satisfied. That's why ethers also possible. Now we move to the number of alcohols and number of ethers. First, alcohol. Alcohols you write down first. How to write the alcohols? First point, 5 carbons. 5 carbons possible chains. You write down. This is what? Neopentane chain. Neopentane. 5 carbons chain. 5 carbons chains. Number of chains. Chain isomers you write down. Chain isomers. Only 5 carbons means what? See, this is the neopentane. Next one is what? Isopentane. What is this name? Isopentane. You remember this one formula. Next one, N-pentane. N-pentane means straight chain. N-pentane. N-pentane. So if you want the hydrogens, number of hydrogens not certain. How many hydrogens here? 3, here 3, here 3, and here 3. So 12 hydrogens, C5H12. First we write the number of chain isomers for with 5 carbons. So 3 chain isomers are possible. One is neopentane, isopentane, N-pentane. This is the way how to prepare this number of isomers, C5H12 isomers. One by one you take the one each chain, carbon chain. Okay, that is the second step. This is the step 1, students. This is the step 1. Step 1, number of chain isomers written. Step 1. Next, step 2. Each chain isomer you take. The second step. What is the first chain? Number 1, this chain. Carbon, 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 carbon with carbon. So for this carbon chain, neopentane chain, how many OH groups for this one? You write down here. For this chain, Here C, C, C and C. Here OH group. So this is only possible. You know molecular formula same only, C5H12 only. You calculate, verify that. This carbon how many hydrogens? 2. This is the 3. CH3. Again one CH3. Again it is also CH3. This carbon having CH2. So formula satisfied. C5H12O. This one. What is this IUPAC name? 1, 2, 2 dimethyl. IUPAC names are very important. They play a very important role. 2, 2 dimethyl. Dimethyl prop in 1 all. So by using this one, only one isomer possible. You write an OH here also same name. You write an OH here completed. If you write the OH group here or here or here, all 4 carbons are same. So how many alcohols? Only one isomer only possible. What is the next chain? Isopentane chain. You write an isopentane chain, carbon, carbon and carbon and carbon. So same chain you write down here, carbon with carbon, carbons. So if you write down the OH group here, same marker formula you got. What is the IUPAC name? You write down IUPAC name of this. Next same chain. Here I written one OH group. Next here you write down. So same carbon, 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 carbon. So here OH group. So these two are different. How you know that? If you write down the IUPAC name, write down IUPAC name of this. IUPAC. You write down IUPAC name of this also. IUPAC. Different IUPAC names. That is the trick. Next one. Here I written OH group. The next structure here you write an OH group. So that is the third structure. Carbon, carbon, again carbon, carbon. So here you write down the OH group. So this is different. How you know the different? You write an IUPAC name. These got the different IUPAC names. So here also completed. Written this. Next here you write down same carbon chain. Next here completed. Next you write down here. So carbon and carbon, carbon and carbon. So OH group take this one. OH group. See that this compound IUPAC name different. IUPAC names are different, all these 4. Then again if you write down the OH group here, you got the different product. If you want to write down the cross check here OH group, for example I wrote that one also. I write that one also. Carbon and carbon. Here also carbon and carbon. Then if you write down the OH group here, OH group. So these two compounds IUPAC names are same. Same IUPAC names. Same IUPAC names. Then I will give the IUPAC name same also. What is that IUPAC name? Numbering 1 this side. 1, 2, 3, 4. Here also same numbering. 1, 2, 3, 4. What is the name? 2-methyl. 2-methyl butane. Butane. What tell me? Alcohol at 1 carbon. 1 ol. This name for this one same IUPAC name. So IUPAC name same means these two are same. But if you write down this one numbering, IUPAC numbering, which side? 1, 2, 3, 4. So what is this IUPAC name? 2-methyl butane 2-ol. And numbering this side because function group this side. So 1, 2, 3, 4. So what is this name? 3-methyl butane 2-ol. 3-methyl butane 2-ol. Then if you write down the IUPAC name of this numbering 1, 2, 3, 4. What is this name? 3-methyl butane 1-ol. So total how many? These two same means this is considered as one only. These two same. So total how many? This is 1, this is 1, 2, this is 1, 3. These two are same, one only. So total by this chain 4 isomers you got here. Total how many? 4. This is 1. What is the remaining chain? N-pentane. 1, 2, 3, 4, 5. For this N-pentane, okay. How many are possible? If I write the OH group here, here I write the OH group. What is this name? 1-pentanol. Simple IUPAC name. 1-pentanol. The next same structure, carbon, carbon, carbon and carbon. If I write the OH group here, what is this name? 2-pentanol. 2-pentanol. And if I write the IUPAC, another one, same structure, same skeleton. This skeleton only taken, this carbon skeleton only. Then if I write the here OH group, then what is this name? 3-pentanol. 3-pentanol. So for this carbon chain, total how many? 3. That's why number of isomers, total alcohols, not total structural. 1, here 1, 4 and here 3. Total how many? 8. 8 alcohols. 8 alcohols are possible for this. 8 alcohols. Next, number of ethers. So in this one trick also there. If anyone asks the compare to these two, which isomers? Here carbon chain is different, therefore these are chain isomers. If anyone asks the relation between these two, these are which isomers relation. In this one, carbon chain is same, so these are not chain isomers. In these two, carbon chain is same. See that in this one, carbon chain is same, so these are not chain isomers. In the chain isomers, what is the important point? Carbon chain different. So these two chains are different. No, same. But these two carbon chains are different. That's why these two are chain isomers. These two carbon chains are different. Therefore, these two are chain isomers. This is the way. This is also useful to predict the chain isomers also. So we are in number of isomers. 8 alcohols we got it. The next number of ethers. This side we got the C5H12O number of ethers. So this is also how to predict it technical. First ethers means oxygen. Oxygen, 1 carbon left side, 4 carbons right side. That process. So 1 carbon means this side 1 carbon I written CH3. 4 carbons means what? CH2, 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 again CH3. Now you know that with 4 carbons how many alkyl groups? This is N-butyl. Just now we discussed basic point. Total how many butyls are possible? 4 butyls. Next butyl is what? Isobutyl. Instead of N-butyl you write an isobutyl. Next one is what? Secondary butyl. Next one is what? Tertiary butyl. So total how many? 4 possible with ratio. This one 1:4. So I write the N-butyl I written here. What is this? N-butyl. Then I write the isobutyl also with ether. This is CH3. This side 1 carbon and oxygen. Isobutyl you write down. Isobutyl means what? CH2, CH3, again CH3. Next what is that? Secondary butyl you write down. 1 carbon and 4 carbons. Here CH3, oxygen. Secondary butyl means what? CH, here CH3, CH2, again CH3. This is the secondary butyl. Next one is what? Tertiary butyl. CH3, then oxygen, carbon with CH3. Here also CH3, then CH3. So what is this one? Tertiary butyl. So this alkyl group name is what? N-butyl. And this alkyl group name is what? Isobutyl. And this alkyl group name is what? Secondary butyl. And this alkyl group name is tertiary butyl. So total how many? 4 we got it. 4. 1 carbon left side, 4 carbons right side. Next ethers. 2 carbons and 3 carbons, another possibility. Same here, oxygen. Here which, how many carbons? 2 carbons. This side 3 carbons. So you write down oxygen. 2 carbons means which group? CH3 and CH2. What is this group? Ethyl group only. By using number of 2 carbons alkyl only 1. Then 3 carbons alkyl how many? 1 is what? CH2, CH2, again CH3. What is this name? N-propyl. N-propyl. But we know that 2 only possible. So what is another one? CH3, CH2, O, next CH, CH3 and CH3. What is this name? Isopropyl. So only we know that N-propyl isopropyl, enough. 2 and 3 completed. So this ratio is completed. Next what? The next possibility no. So if you write down 3 carbons again, and here 4 carbons I changes. Here 4 carbon go to here at 2 and 3. If you change again once here, 1 carbon to 3 2 same. Same means what? If oxygen, 1 carbon shifting after this. Here 3 carbons, here 2 carbons. So both are same. That's why for this combination, what is this alkyl group name? This is N-propyl. And what is this alkyl group name? Isopropyl. That's all. So here with this ratio how many? 2. With this one 4. So 4 plus 2 how many? Total 4 plus 2 6. Therefore 6 ethers. How many ethers? 6 ethers are possible. 6 ethers. This is the way how to find the number of alcohols. In this page, how many alcohols total? 8 alcohols. 8 alcohols plus 6 ethers. So total how many? 8 plus 16? 14. 14 structural isomers. These are structural only. 14 structural isomers. So 1 by only stereoisomers next video, but structural isomers only 14. Very important. C5H12O. Then next one, next molecular formula C6H10. C6H10. For this one, what are possible? This is hydrocarbon. For hydrocarbon, hydrogen and carbon is there. Now, for hydrocarbon, what is possible? Alkane and alkene and alkyne is possible. So need not to remember the degree of unsaturation. 6 carbons alkane, you write down one time. 6 carbons alkane. Okay. I write here CH3, CH2, 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 again CH2, CH3. So how many carbons? 1, 2, 3, 4, 5, 6. Okay. Hydrogens how many? 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 2, 11 plus 3, 14. But here 10 only there. So this is alkane. Alkanes are not possible. Next you can check alkene. CH3, CH2, again CH2, again CH2, CH double bond CH2. This is alkene. So carbons are 6 only. But hydrogens are 3 plus 2, 5 plus 2, 7 plus 2, 9, 10, 12. So but here 10 only there. So alkene also not possible. Then alkyne you write down. CH3, CH2, 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 C triple bond, CH. This is the alkyne. So total how many carbons? 1, 2, 3, 4, 5, 6 carbons. Hydrogens how many? 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 1, 10. So this is the project and practice. If you not remember the degree of unsaturation. So alkynes are possible. You know, if they can ask the number of alkynes, how many? Our question is one, C6H10, number of alkynes. Number of alkynes. How many alkynes only? we discuss here. Important. This one only in NCRT. In NCRT, this is only useful. Number of alkynes. See that how it is predicted now here. Same basic formula. First you write down one compound. What is that one? CH triple bond C, CH2, CH2, again CH2, again CH3. So this is the one hexane, you know this name. But here you round up this alkyl group, round up this. What is this group name again? N-butyl. N-butyl if it is comes, immediately write down 4 butyls. What is another butyl? Secondary butyl possible. CH triple bond C. Secondary butyl means okay. CH CH3, again CH2, again CH3. What is this butyl group name? Secondary butyl. It is the secondary butyl. Next butyl is what? Here I write the next butyl. CH triple bond C, then CH2, again CH, CH3, CH3. What is this butyl? This butyl is isobutyl. Isobutyl group. Next what? Immediately CH triple bond C, CH3, again CH3, again CH3. So what is this butyl group name? It is a tertiary butyl. Tertiary butyl group. That's why total with this for triple bond, this side 1 carbon triple bond and this side 4 carbons. So this side for triple bond 5 carbons, but hydrogen you select. This side hydrogen means 0 carbons for C triple bond C. This side how many? 4 carbons ratio. It is therefore 0 and 4. This is 0 and 4. So here see the step 1 it is first step. In the first step, see here. What is the formula? C 6 H 10. What I written first? C triple bond C you write. For C triple bond C, this side how many carbons? 0 carbons. And this side how many carbons? 4 carbons. This is completed. This is completed. How many it gives rise to? 4 isomers. It gives 4 isomers. How it is? In this one, what first you write down? N-butyl. N-butyl. Next one, isobutyl. Next, secondary butyl. Then tertiary butyl. This is over. Step 1. Next, second step. In the second step, same C triple bond C. Here, this side how many? 1 carbon. And so remaining how many? Here 1 carbon, here 2. 3 over. So remaining how many? 3 carbons. And now you try this one. How many are possible by using this one? Okay, C triple bond C. 1 carbon means CH3 only. Only methyl group is possible. Next here 3 carbons means what? CH2, CH2, CH3. What is this name? It is N-propyl. We know that in the basics. 3 carbons alkyl groups, how many? Only 2. One is one N-propyl. And another one is one isopropyl. Here I write the isopropyl also. CH3, C, triple bond C. Next one, CH, CH3, again CH3. So what is this group? Isopropyl. So only 2 are possible. That's why for 1 and 3, here how many isomers possible? Total 2 only. Here how many? Total 4 only. Next, if you change the 1 carbon here, 2 carbons, 2 carbons. First minimum starting, step 1. Next step 3. Third step, what you can do? 1 carbon bring this side. Here 4 carbons, 1 carbon bring this side means 0 becomes 1 carbon. 4 becomes 3. In the next step, you can change the 3 carbon, out of 3, 1 carbon here. So here C triple bond, C triple bond. See here how many carbons? 2 carbons it becomes. 2 carbons, and here how many? 2 plus 3, 4 completed. 6, here also 2 carbons. Total 6. So out of 3, 1 bring this side. So here remaining 2. 2 carbons, alkyl how many? Only one alkyl. Only one alkyl group. What is that group name? Ethyl. Ethyl group. So you write down C triple bond C. Here one ethyl group CH2 CH3. Here also same ethyl group CH2 CH3 CH3 and CH2. Here ethyl group. Here also ethyl group. For ethyl group there is no another isomer. Only one ethyl is there. That's why for this 2 and 2 combination only one alkyne. So here how many alkynes? 2. Here how many? 4, 6. Plus here how many? 1, 7. That's why total how many isomers are possible for this one? Total 7 isomers possible. So this is the way how to find the C6H10 isomers. Very important. Okay, next, the same way, if you want the another isomer is the C6H12O number of C6H12O number of ketones we discuss. Ketones only. C6H12O number of ketones. Marker formula is this C6H12O. So total carbons how many? 6 carbons. It satisfies the ketone only. You write down one ketone structure C6 CH3 CH2 C double bond O, again CH2, again CH2, 1 2 3 4 5 and 6. So hydrogen 7, 3 plus 2 5 plus 2 7 plus 2 9 plus 3 12. Hydrogen satisfied. 6 carbons, 1 oxygen. So ketone okay. Now here also trick, see that number of, we discussed not a total structural isomers. This is what? Number of ketones only. It is also trick. See the trick now. First here what is the functional group? C double bond 1. Now C double bond 1 means 1 carbon is over. Out of 6 carbons, the remaining 5 carbons are remaining. This side first you can write down 1 carbon. 1 and 2 completed. 4 carbons. This side how many carbons are remaining? 4 carbons. So you write down 1 carbon ketone. Here want CH3 bond C double bond O. Next what is this? 4 carbons means just now we discussed total 4. 1, 2, 3, 4. One is which group you write down? N-butyl. Another one isobutyl. Next secondary butyl. Then tertiary butyl. So what is the 1-butyl structure I written? N-butyl. This is okay. CH2, 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 again CH3. So this is which butyl? This is the N-butyl. We know that. Next, immediately write down 4. CH3, C double bond O, CH, again CH3, CH2, again CH3. What is this butyl group name? Isobutyl. Next, CH3, C double bond O. Next, CH, sorry, this is the secondary butyl. Secondary butyl. Next, what is this? CH2, again CH, CH3, CH3. What is this butyl group? It is the isobutyl group. Iso. Then next one is what? Same. One side CH3, CH3, C double bond O, C. Here also CH3, CH3, again CH3. What is this butyl group name? It is a tertiary butyl group, tertiary butyl group. So this is the n-butyl, and this is the secondary butyl, and this is the isobutyl, and this is the tertiary butyl group, tertiary butyl group. So with this ratio, total how many? 4 only. In this one logic point is there. In all these 4 isomers, C double bond O CH3 group is there. C double bond O CH3, C double bond CH3. So for this formula, for ketones, these all 4 are gives positive haloform test. This is very important point. Positive haloform test. What is the haloform test required? C double methyl group containing ketones. These are what specialty? Methyl group having containing ketones gives positive haloform test. So in this all 4 isomers, methyl group ketone, here also methyl group ketone. So 4 isomers gives for this formula, 4 isomers gives positive haloform test. The next possibility, 1,4, next one carbon bring this side. So C double bond O. Ketones, we are discussing number of ketones only. C double bond O. Here how many carbons completed? 4 carbons, and here 1 carbon completed, this one. So you can change 1 carbon here to here. So after shifting, here how many carbons? For C double bond O, here 2 carbons, and here how many carbons? 3 carbons, 1 carbon less. So write down 2 carbons here, how many? C double bond O, here one CH3, again CH2. This is what, which group it is? Ethyl group. And 3 carbons alkyl is one. One is what? We know that 2 isomers only possible. One is N-propyl, another one is isopropyl. First I write down CH2, CH3. What is this group name? N-propyl. Next what is this? C double bond O. Same. CH3, again CH2. Next propyl is one. CH3, again CH3. What is this group name? It is isopropyl. Which group it is? A isopropyl group. So one is N-propyl group, one is isopropyl group. For 3 carbons, 2 only. One is which group? N-propyl group. Another one is the isopropyl group. That's why with this combination, total how many? 2 N-propyl isopropyl, 2 only. This combination, 2 isomers only possible. Here, next what you can do? 3 again changes here to here. 3 carbons once again if you can changes here. Here 3 carbons for C double bond O. Left side how many carbons? 3 carbons, and this side 2 carbons. So already same. Both are same. 3 carbons, 2 carbons, both are same. That's why this is need not to discuss, because both are same. So for this one 2, this combination. For this combination how many? 4. For this combination how many? 4. So 4 plus 2, total 6 ketones. 6 ketones are possible for this molecular formula. So number of ketones C6H12O. Then next one is N-propyl, isopropyl. Okay, 2. And here 3 carbons and 2 carbons. Same. Next one, again 2 carbon, if you can change 4 and 1. So number of ketones, how many possible? 6 ketones only. We got it here. Once again we cross check. Here how many? 4 carbons means 4 isomers. N-butyl, secondary butyl, isobutyl, next tertiary butyl. Okay, right. Next you can change here 2 carbons, 3 carbons, N-propyl, isopropyl. If you can change once again here 3 and 2, that's why we got the same. So we got the 6 ketones. Next one, next last molecule formula, C6H14O. Number of alcohols. Last formula, C6H14O. Number of alcohols. Number of alcohols also. You can use the same trick. Then if you want this trick, we can discuss in the next video. So here 3, 19, E. Then you can find out this, what is this meaning in the chemistry. So I will reveal that. What is the 3 element? Lithium, Li. 19 element? Potassium, K. E as it is, so Li.